So today and tomorrow and Friday, so 210 and both days of 211 are all just going to be more application problems of systems, okay? What I don't care about is how you solve the system. All of these application problems would be calculator parts, okay? I do not care if you use reduced row echelon form like we talked about yesterday, Gaussian elimination. I do not care if you use A inverse B like we talked about a couple days ago. I don't want you, though, to spend time solving these by hand, okay? There are numbers, there are too many variables. It's not what we are looking for to have you solve these by hand. So try not to let that be your go-to, okay? While we are working through these, and like I said, we're going to practice these for the rest of the week. And then on Monday we review, and then on Tuesday is your test. What I do want you to pay attention to are a couple different things. Every single application problem, you are to define your variables, set up your system, and then solve or answer the question that you're being asked. So those are three things. Some of y'all, when you get your quizzes back from last Friday, you're going to notice that you lost points for not defining your variables, okay? Got to make sure you're defining your variables to help yourself out, okay? So let's look at number one. Last Tuesday, AMC Studios sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of three ways. Matinee admission costs $5, student admission is $6 all day, and regular admissions are $8.50. How many of each type of ticket was sold if twice as many student tickets were sold as matinee? So this part right here, how many of each type of ticket was sold, that's what's going to help you decide what your variables are. That's what they're asking us for. How many of each type? So let's let X, what do you want X to be? Matinee tickets, okay? So we would say number of matinee. Y we could let be number of student tickets. And Z we could let be number of regular. Okay? Now let's set up our equations. So we have three variables, so how many equations do we need? 3. So a total of 8,500 movie tickets. How could I write that as an equation? Good. X plus Y plus Z equals 8,500. Proceeds totaled $64,600. How much did each matinee ticket cost? So 5X plus, how much did each student ticket cost? So 5X plus 6Y plus 850 Z is going to equal 64,000. All right, this part's the tricky part. Twice as many student tickets were sold as matinee tickets. So when you get one of these, here's how I think about them. 64,000, oh, 600. All right, well, you heard my lament about not having a eraser, so that's a 6 right there. 64,600. Thank you. All right. Twice as many student tickets were sold as matinee tickets. So when you see one like this, I want you to think, which one did you sell more of? Student. So whichever you sell more of, that's what's going to be with the equals. So Y equals twice the number of matinee. So 2X. Right? All right, I'm going to practice setting this one up using our process from yesterday of Gaussian elimination. So to do that, we write an augmented matrix. What's going to go in our top row? 1, 1, 1, and then 8,500. Then 5, 6, 8.5, 64,600. Okay, let's be careful about our bottom row. How do I rewrite this? Okay, you can subtract 2x over or you can subtract y over. It does not matter as long as you are consistent. So I'm going to move my 2x over. So negative 2x plus y plus 0z equals, what's left when you subtract that over? 0. So negative 2, 1, 0, 0. All right, so go ahead and enter that into your calculator like we did yesterday. If you need help, let me know. I'm not going to pull out my calculator because I don't want it to crash the video. You're doing it just like we did yesterday, so go into your matrix, and then you're going to go into math and select reduced row echelon form. It's B from your list. Check what you're getting on your calculator with people sitting near you. Make sure you're getting the right things. And when we write our answer, be sure that you are writing using our units. So, how many, your solution matrix, when you get it on your calculator, was 1, 0, 0, what? 900? And then 0, 1, 0, 1800. And then 0, 0, 1, 5800. That's what you should have gotten when you did your RREF, right? Okay, so what that means is 1 is in the X spot. So X was matinee. So how many matinee tickets? 900 matinee. What is the 1800 representing? It's in the Y spot, right? So 1800 student and 5800 regular or general. Sorry, I already started writing general, but it means regular too. Okay? If you just wrote 900, 800, and 1800 and 5800, I could not give you full credit. Okay? Have to have your units. Have to have your let statements, have to have your equations, your work, and then your solution. Okay? All right, let's go to number 2. Okay, a cashier has 25 coins consisting of nickels, dimes, and quarters with a value of $4.90. If the number of dimes is 1 less than twice the number of nickels, how much of each type of coin does she have? All right, so what's the first thing we're always going to do? Good, define your variables. So we can use N, D, and Q, or you can use X, Y, and Z. It does not matter. What do you want to use? X, Y, Z. So what do you want X to be? Good. Number of nickels, because it says how many of each. So number of nickels. Let's let Y be number of dimes. And let Z be number of quarters. Okay, after I define my variables, then what do I do? Write our equations. 3 variables means I've got to have 3 equations. Ideas for our first equation. Good. Using this 25 coins, x plus y plus z equals 25. So that's how many, that's a number of coins. This is not talking about value. What would be another equation? Good. Be careful there. 0.05x, not 0.5, plus 0.10y plus 0.25z equals what? 490. Okay, so we have a number equation, then we have a value equation. Okay, the number of dimes is 1 less than twice the number of nickels. So number of dimes, so what's representing dimes? So number of dimes, y is means equals 1 less than twice the nickels. So remember, less than, you always send it to the back, right? So twice the number of nickels, so 2x minus 1. All right? I'm going to set it up for the A inverse B method, just for another practice. You can remind yourself which one you like better. Okay? So I'm going to write my A matrix. Remember, it's A inverse times B. Where do I get the values for my A matrix? The coefficients. So my top row would be 1, 1, 1. My middle row, 0.05, 0.1, 0.25. Be careful about this one. We have to rewrite it, right? So subtract 2x from both sides. So I get negative 2x plus y plus 0z is equal to what? Negative 1. So negative 2, 1, 0. So I want the inverse of that matrix times what goes into matrix B? The solutions. Good. So 25, 4.9, and negative 1. All right, so remember, you're going to enter this one into A and this one into B. And then to type it into your calculator, you're going to go get matrix A, take the inverse of it, times B. So try it this way just to kind of refresh your memory. All right. So what do we get? What do we get for X? What do we get for Y? What do we get for Z? And what do they mean? Okay. All right. So 3 represented what? 3 nickels. 5 dimes. And 17 quarters. Questions? Okay, I want you to solve number 3 on your own. Okay, define your variables, write your system, and you can solve it either way. You can use A inverse B, or you can use reduced row echelon form. It's totally up to you, but show your setup so you can get points for how you solve it. Okay? All right, so everyone's trying number 3, please, on your own. Going to pause the video while we solve. Okay, so let's check back in for a sec. Hopefully we defined our variables, double check because you don't want to lose points for that, okay? And any questions about the first 2 equations? All right, so let's pay attention to that last one. 20 fewer roses than daisies. Okay, so what you want to think is you want to try and think of this in terms of real world numbers, okay? So 20 fewer roses than daisies. So if I had 100 daisies, how many roses do I have? 80. So what are you subtracting the 20 from? You're subtracting the 20 from daisies. So roses Y equals daisies Z minus the 20. Okay? Those are tricky. Trying to word those correctly are tricky. Go ahead and finish solving this though. Either method, don't care which one you use. Should have gotten 80 carnations, 50 roses, and 70 daisies. Questions?
Yeah.
Oh, so you moved Y, and you subtracted, so you can add it. Okay, let me check the matrix. Oh, usage. You flipped this. That's what we'll be talking about. That if there's 20 fewer roses than daisies, it's going to be roses Y equals daisies Z. Okay? Okay, we're going to work one more together, and then I'm going to let you get started on your homework. So we are going to go to number 5. Okay? Number 5 is one of those distance, rate, time problems. Okay, we worked one last week. Told you not to worry about it for your quiz, but you do need to worry about it for your test. Okay? So the setup is going to be very similar each time. So make sure you are all with me. I wouldn't be paying attention to anything else but what we are doing right now. Okay? There are people every year that miss this problem. Lots of them. So I want us to try and beat that. Okay, As soon as we see a situation with two people or two cars and something about rates and traveling and all that stuff, we know that we are going to set up these systems using our equations. Distance equals rate times time. That's how we are going to approach these problems every single time. Okay? I'm not saying this is the only way, but this is the way that I think works the majority of the time with the least amount of work. Okay, so Pete traveled at 16 kilometers per hour. Sam, an hour later, traveled at 22 kilometers per hour. How long did it take Sam to catch up with Pete? Okay, notice who is it asking us about? Sam. So what's super important here is that you define your time, and I recommend that you use the time that you're being asked about. So I'm going to let T be Sam's time. Now, you are not wrong if you choose Pete's time. It's just a little trickier because you've got to remember to change it at the end. So I'm going to let T be Sam's time. Okay, so I'm going to write two equations because I've got two people. I've got Sam and I've got Pete. Always write the easier equation first. So in this case, T was Sam's time, so let's write Sam's equation first. So distance equals, what was Sam's rate? 22. And then T we defined as Sam's time, so it's just T. Okay? All right, let's talk about Pete. P is still going to be D for distance because they're traveling the same distance. What's Pete's speed? 16 kilometers per hour. As soon as you write down the second speed, immediately open your parentheses. Okay? Because we're going to have to manipulate Sam's time to turn it into Pete's time. Okay? So, was Pete traveling for a longer amount of time or a shorter amount of time than Sam? Longer, because Sam left an hour later, right? So Pete was traveling for an extra hour. So I'm going to do plus. How much longer was he traveling? 1 hour. Now, what is it important to double check here before I write that in? The what? Yeah, to see if we're in hours. We've got to make sure that our time matches our rate. So we have hours, and 1 represents an hour. What if it had said 30 minutes? Yeah, I would use 1/2. Okay, because you always have to put this guy right here in terms of hours. You might want to write yourself a little reminder about that. That this has to be in terms of hours. Okay, now personally, to solve this, I don't think matrices are the easiest way. You've got to do a lot of rearranging. But notice that both of these are equal to D, right? So can I just set them equal to each other? All right. So 22T equals 16 times T plus 1 in parentheses. So 22T equals 16T plus 16. Then what? Subtract 16T, right? On both sides. So that gives me 6. Sorry. No eraser. 6T equals 16. Then divide by 6. So T equals 8 over 3. Okay, what is that we just found? Good, and I know that because I wrote it up here, right? If you don't write it up here, you're not sure if you found Sam's or Pete's. So we want Sam's time in hours and minutes, it says. So 8/3. What is that? Yeah, 2 2/3 hours, right? And each third of an hour is 20 minutes. So 2 hours and 40 minutes. Okay? Put a star by this. Make sure you're going to keep practicing those distance rate times ones, okay? Because you will see that. All right. You got some time to get started on your homework.